Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with DevExpress controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Lin Clark. She works in the Emerging Technologies group at Mozilla. She also draws code cartoons, and this is actually how I started to get to know you at code-cartoons.com. Thanks for hanging out with me today.
Well, thanks for having me on the show. I'm really happy to come and chat with you about this stuff.
Yeah, I appreciate what you're doing. When I go to Code Cartoons, it looks almost like kind of an XKCD style. I think that XKCD basically gets to claim stick figures.
Yeah, that's true. I've collected a bunch of different stick figure comics when I was first starting out, and I've never put them chronologically. So I'm not sure if XKCD was actually the original one, but yeah, that was definitely a big influence on Code Cartoons.
Wow, that might mean that if we go back and do the math, maybe you were first in XKCD.
I can assure you that's not true.
Yeah, I really like the detail and the level of effort. These are not these are artistically done. I think I'm looking at one on a cartoon intro to Facebook's Relay. And is that the guy from the IT crowd buried in the back there?
Yeah, I like to put little Easter eggs in there. So that is Maurice Moss.
That's so awesome. I definitely recognized his hair. These cartoons they're not just cute, but they're extremely accessible. They make complex concepts available to the masses where the masses are me. I really find specs really overwhelming, and somehow you just have the right amount of code, the right amount of cartoon, and the right amount of prose. You should do more.
Well, I'm very excited. I started Code Cartoons before I joined Mozilla, and then I joined Mozilla, and it was my side thing. And then I realized I could probably actually turn this into my full-time job at Mozilla. So I talked to my current boss about that idea, and he was thrilled about it. So I'm very lucky that now it is my full-time job, and I'm getting to do more and more of them.
Really?
Yes.
Wow. I did not realize that. That's cool.
Yeah. So I, unfortunately, codecartoons.com, I'm not doing a great job of keeping it updated. I need to go in and revise it so that it's no longer just a Medium blog. But I have a lot of Code Cartoons now on the Hacks blog for Mozilla. Things about memory management and shared array buffer and atomics and WebAssembly. And I'll also be releasing one next week about a new project that we're working on at Mozilla called Project Quantum, and particularly Stylo.
Oh, okay. So that's at hacks.mozilla.org. Yeah, it'd be great if we could get all the cartoons in both locations.
Yeah, we'll make sure that's in the notes.
So Project Quantum and Stylo, are those two things or the same thing?
So it's a little bit complex. Project Quantum is something that we're doing at Mozilla. We've been doing it for the past 9 months or so, and it's going to keep going for a while yet. We're making Firefox faster. And we're doing that by bringing in technology that we've been researching over the past 4 or 5 years and bringing it in and swapping out components as we go in Firefox. So, for example, Stylo, which is the first of these components to land in Firefox, is the CSS style engine. We're basically completely rewriting the way that we do CSS styling to make it much, much faster.
Okay, so Project Quantum is the let's make it fast, and then there's code names for each individual, organ, for lack of a better word, that you're swapping out of the larger body.
Exactly.
I hear each year as the browser, kind of the browser wars, the long tail of the browser wars continues, that, this thing is 30% faster or that thing is 30% faster. And whenever I hear someone come out, like I think Edge came out with something that was like, oh, we're 200% faster. And I'm thinking to myself, but doesn't that mean you were slow before? And it's year after year after year. If we look at this over the last 10 years, it must be thousands of times faster. How is that possible? Is that a computer science thing, or did we just really all suck before?
Well, yeah, the different parts are getting faster in different ways. Mm-hmm. So one of the parts that has gotten faster in the past that really blew people's minds was JavaScript got a lot faster about 10 years ago. That was the original performance wars that people were talking about. And that was because of changes in the ways that we compile JavaScript in the browser. And we're actually in that space, in, that kind of the JavaScript space, we're actually seeing another huge performance boost now from WebAssembly. But there's also another part of the browser, the rendering engine. And that's what takes your HTML and CSS and turns it into the pixels on the page. And so that is what a lot of the work in Project Quantum is about. Not all of it, but a lot of it is about making that rendering engine faster.
The engine I'm familiar with, or at least I've been familiar with for the last several years, and I think of when I think of Mozilla, is I think of Gecko. Is this a swapping out of Gecko, or is this a generational improvement to the original Gecko?
It's swapping out parts of Gecko with another project we've been working on called Servo, which is another web engine. And so I'm going to give a little bit of background about Servo because I think that that'll help inform why we think that there's such performance gains to be had here. So to talk about how you make the browser, the rendering engine faster, I need to talk a little bit about the hardware that these browsers are running on and the hardware that's likely to come in the near future. And to do that, I'm going to need to talk a little bit about Moore's Law and the end of Moore's Law. So Moore's Law is basically why computers have gotten faster so quickly over the last 60 years. And it's basically this observation that was made by Gordon Moore, who was the co-founder of Intel, that you could fit more transistors, about twice as many transistors on a chip every 18 months. And so that is it's a confusing way to put it, but basically there's a correlation between the number of transistors you can put on a chip and how fast the computer goes. And so Gordon Moore said, this is probably going to continue into the foreseeable future. So we were getting, basically 2 times performance increases in how fast the computer is going every 18 months to 2 years for the last 60 years. And then about in 2005, people started seeing that we were reaching physical and economic limits to Moore's Law. Basically, we weren't going to see these continued performance increases from being able to fit more transistors on a chip and being able to run what's called the clock faster, to increase clock speeds. But we still want to have that increase in computing performance that we've seen with Moore's Law over the past 60 years. We still want the computers to get faster. So chip manufacturers started to design chips in a different way. If you think of a CPU as basically a brain, it can think things. These new chips, they were called multi-core architectures. It was basically like having multiple brains on the chip. So you could think multiple things at once. But in order to make use of that, you need to change the way that you code. You actually need to start coding in parallel. And so browsers started taking advantage of this in 2007 and 2008. That's actually, Chrome was one of the big innovators here. That's one of the reasons why Chrome was faster than Firefox when it first came out, was it was taking advantage of these multi-core architectures with this multi-process architecture. And so what that means is that it would have the URL bar, the stuff that you use to navigate the page, that's called the browser Chrome. It would have that running in one process, which could be running in one core, so it could be running in one of these brains. And then the actual web contents, the page, so the HTML and CSS stuff, that could be running in a different process that was running on a different core, potentially. And each one of these tabs could be running in a different process, up to about 10 tabs, if I recall correctly. So they actually started making use of this parallelism in 2008. But that's a pretty coarse-grained kind of parallelism, having just each page of of each tab be running in a different process. Mm-hmm. And it doesn't buy you much in certain circumstances, like on phones, where you really only want to have one tab that's active at a time. We started on that same kind of multiprocess, that same kind of coarse-grained parallelism in Firefox. I think we started around 2013 on implementing that. But we also started at the same time looking at finer-grained parallelism. So looking at how you could break up the page itself, the contents, the actual web contents, and run that in parallel as well. And so that was what the Servo project was researching, is how can you parallelize all of the things in a web page? So we don't just parallelize the tabs to different processes, but we parallelize, if you have something like Facebook or something like Pinterest, those individual cards could be processed in parallel. And so once we saw that this was possible in the Servo project, that's when we started swapping out the parts of Firefox engine with the parts of Gecko with these components from Servo. And so the first one that I was talking about before, Stylo, that landed in our nightly release, which is a kind of a release that you can use if you're on the bleeding edge and you don't mind your browser breaking occasionally. That landed a couple of weeks ago in nightly.
Okay, can I run nightly side by side with my stable and not be fearful?
If you run it with different profiles, you have to run it with a different profile, but other than that, yes.
Okay, that's cool. That seems totally reasonable. So it seems like in order to make it feel like the Moore's Law curve continues in its kind of dramatic fashion, we're doing anything we can to keep with that curve. And it's parallelism in the last 10 years that have become the big issue. It seems, though, that at least the C and C++ language that I learned in college 20 years ago, they didn't tell us much about, asynchrony, and they didn't tell us much about parallelism. It doesn't feel like C++ is really good at that.
Well, C++ can do things in parallel. And a lot of people who write C++ will contest that it's just fine for that. But you kind of need to have a wizard level understanding of safety and, you basically have to not make mistakes at all when you're working in parallel with C++, because there's no guardrails. And when you have a project that has hundreds or thousands of engineers working on it, you can't really, you can't take that risk. So one of the things that we did as a precursor to working on Servo was actually, we sponsored development on this language called Rust, which is a programming language that gives you what's called fearless concurrency. Basically, it takes care of making sure that you don't have these kinds of bugs that you can have in parallel code, and make sure that your code doesn't compile if you do something that might lead to one of those bugs. And so that's the way that we can really be confident in the parallel code that we're writing.
I see. So, I mean, no disrespect to C people. I don't want to get letters from the C mafia. But certainly it's C and C++ have grown over the years. But it sounds like I'm hearing you say that there's new languages, Rust being, of course, the primary one, that are coming along in a world where we went from not one processor, but like hyper-threaded multiprocessor systems with, you might have a dozen or more potential processors that you could run code on. It might be asking a lot of C and C++ to do that. So why not just bake it in from the very beginning at the language level?
Mm-hmm. Yeah, and make sure that it's safe enough for your average developer to do without having to learn all of the nitty-gritty memory stuff.
Right. Well, it's just great for an open source project because you don't want to come into a C++ workflow that 100 people are working on before you and introduce some subtle bug that ruins it for everybody.
Mm-hmm. Yeah, okay. One of our Gecko engineers actually has a sign that I think is like 7 feet high that's you must be this tall to write multi-threaded code. That was, of course, before Rust, but...
Yeah, yikes. I don't know. I think people of all heights should be able to write multi-threaded code, so it's good to know that you've done that. So it sounds like one of the main aspects of Quantum to get this This high performance is the parallelization at a level of parallelization maybe we haven't seen before. And then one of the things I was realizing, I saw a tweet recently when someone was talking about their first video card, and they talked to me about their Voodoo FX video card. It was the first 3D accelerated video card. And it made me realize that even my non-technical parents have 3D accelerated video cards that they didn't even know. Like the idea of even having a GPU went from being an elite gamer thing to being like anyone who has a pocket supercomputer.
Totally. Yeah. So that's another big project that we're going to be working on. One of the things that we worked on in Servo is called web render. And that's making better use of the GPU. Because if you look at the way that chips have been developing over the past few years, they're not adding new CPU cores a lot of the time. As they get more space available on the chip, they're expanding the GPU. So we need to make sure that we're making the best of use of that GPU in addition to parallelizing things across the CPU cores. So that is going to take care of part of the pipeline, the rendering engine pipeline. Basically, when you're using the GPU, a lot of browsers actually do have some stuff that they run on the GPU at this point. There's GPU acceleration for things like compositing, and that's been in browsers for years. But NVIDIA, who is one of the major players in the GPU business, they actually came out with a paper in 2012 saying that that's not actually GPU acceleration. Is GPU assisted, not GPU accelerated, because browsers are not actually making the best use of the GPU. A lot of times these browsers, what they're using is called immediate mode. And so basically they're sending commands, they're figuring out how the GPU should do things and sending off commands to the GPU to tell the GPU to do it, and the GPU is doing it immediately. It's actually better if you can just tell the GPU what it should display, if you can just declare that and ship off a graph of that to the GPU and then let the GPU figure it out its own work for itself. And to me, as somebody who's been involved in React, this actually reminds me a lot of React. It's the difference between when you have a framework where you're interacting with each DOM node and telling it what to do versus giving React this virtual DOM and letting React figure out the most efficient way to do the thing.
Okay, that makes sense. So then immediate mode is I thought about it, put it in order, and I gave you, the GPU, the procedures. And then the opposite of that is retained mode, where you give the GPU more responsibility. You say, here's a scene. Figure it out. I know you're good at that.
Yeah. And so,
that's interesting.
Like React, this actually really simplifies things for us as browser developers. Basically, it means that one of the things that we've worked on is basically just re-rendering the whole thing on each frame and that means that you don't need to have, currently in a lot of browsers, there are these things called layers that try and reduce the amount of things that need to change. But with something like WebRender, you can just send off the new scene graph to the GPU and then just have it re-render. And we found with this that, something that will run in Firefox or Chrome currently at 15 frames per second can run in WebRender at 60 frames per second, no problem.
Wow. That's very interesting because I've always felt, even like I'm on Windows, you're on a Mac. Right now, if I go and move my, a couple of windows around or minimize stuff, sometimes I've said to myself, that doesn't really feel as smooth as like playing a full-on 3D video game.
Right.
I thought we were supposed to have solved this problem, and it seems like we still haven't treated kind of that 2D environment with the same care that we have as we're chasing frames per second in the 3D environment.
Right. One of the main developers on WebRender actually said, we're basically creating a game engine here.
Which makes me wonder why we didn't do it before. Yeah.
It's the folks on the Servo team have had a lot of really interesting insights. They've really been looking at these trends in hardware, which I think is you asked before about why we didn't do this before. We weren't really looking at the capabilities of the hardware as closely as we have been with Servo.
That makes sense. So now we have everyone with a GPU of some kind. We have smarter layers that we're sitting on top of. We have things like OpenGL, and we have NVIDIA and other partners that know more, and we really are standing on the shoulders of giants.
Exactly.
So people who are working on Mozilla, are these volunteers or these employees, or what's your ratio of like random people like me to employees?
Well, it's different so Servo really is still its own project in emerging technologies. And then Firefox Engineering are the folks that are bringing the technology from Servo and putting it into Firefox. So Servo itself, I think that there's maybe 12 paid team members for Servo and then hundreds of contributors. And that really is meant to be more of a community project. Firefox Engineering, to be honest, I actually don't know the ratio of paid engineers to contributors on Firefox itself.
Mm-hmm. The reason I ask is that, when you go to the Mozilla wiki at wiki.mozilla.com, it's very welcoming in the sense of, even though it's technical, it's like, hey, look, we have 13,000 plus, unit tests, or what they call ref tests for the renderer. And there's 150 that we're still working on. Why don't you go over to this Google sheet and pick one? And it's like, wow, that's like, I could do this. I could maybe go and try to fix one of these issues. And it's quite organized. Then you go over to Bugzilla and look at the dependency graph, and you can see that there's, 3 bugs that are blocking this graph of other bugs. And you start to get a sense of the organism that makes it all possible. Yeah,
definitely. That is one of the big focuses at Mozilla, is trying to make sure that contributors can take a really active, outside of, non-paid contributors, can take an active role in defining how these different parts work. And a lot of our employees actually do come through, basically start off with a bug or two as contributors and then get more and more involved that way.
And I guess that would be probably a good way to eventually get a job if someone notices you.
Yeah.
So how do you deal with this level of complexity and then trying to kind of bubble it all the way back up to explaining it in something like a cartoon? Or I know that you're an accomplished speaker. It seems like you really have one foot in the silicon and one foot in the in the paintbrush, for lack of a better word.
Yeah, that's true. That's kind of the way it's always been for me. My mom was the one that first noticed it. She was a programmer on Apollo 11, so she understood code. And she noticed that I was really good at working with basically visual language, although neither she nor I understood what that was at the time. And so she actually pushed me to pursue both of those, and actually picked out my school for me. She said, you should go to Carnegie Mellon. And I was like, okay, decision made. So that made things really easy. And so that school actually really focuses a lot on both tech. They have a great CS program, and also they have a world-renowned design program. And so I took classes in both of those. So I really have had a foot in both of those worlds for a long time. And it's actually the most fun thing for me, is diving into the internals of how something works and pulling it apart and figuring out, like, how do these different parts of the system work together? And is this the most optimal way for them to fit together? And so with code cartoons, that's the entire thing. That's the whole deliverable. When I'm working as a developer, I have to do feature work and all of that other kind of stuff. And I only get to do analysis part of the time. But with code cartoons, I really just get to make it all figuring out how things work and how they could work best together. So it's really a pleasure to be able to do that all of the time.
Yeah, and when you're doing that, there's not just the bridging of the artistic and the technical, but there's also the kind of the empathetic aspect of it, because you have to put yourself in the mind of the beginner. And as you go and explain something like, here's an action callback in Redux with bind action creators, and that's pretty dry.
Yeah.
You have to present it in such a way that you keep their attention and that you think about where they came from and where they're going.
Yeah, one way that I actually do that is when I'm drafting, I actually do it all in audio. I record myself telling it as if I were telling it to someone instead of writing. And I find that just like speaking aloud and envisioning the person that I'm talking to helps me humanize it more.
Really?
Yeah.
Do you ever do anything with the audio, or do you just you listen to yourself, explain it to yourself?
Well, I have a transcription program that I can then transcribe it, and it does a pretty good job. Sometimes when I'm saying really weird technical words, it comes up with very bizarre interpretations of them.
Yeah, I call those speechos.
Yeah. So yeah, then from there I can, block it out into short paragraphs and then figure out where I'm going to put the images. I actually will listen to it back and then draw on Post-it notes a sketch of each image as I go through. And then I can just take those off the wall when I finish them and insert them into the written post.
What do you ultimately do the cartoons in then? Do you just do you scan or copy the Post-it?
No, I use a Wacom Cintiq, which is really key. Having a really good monitor that I can draw on and get that immediate feedback as to whether or not what I'm drawing. Because I used to have a Wacom Bamboo where you have to look at the screen, but you're drawing off to the side.
Right,
That
and your
does not
brain
work.
knows that that's bad for you.
Exactly.
I have a cheap Wacom as well, and it's weird to have your hand out of sight while you look at a screen and then try to do all the translation
Exactly.
pixel by pixel. Interesting. Okay. So you're doing the dev, you're doing the coding, you're doing the cartooning all at the same time. That seems like quite the context switch. Or are you multiprocessor yourself?
Well, you know what? I'm actually very, very single-threaded myself. Fortunately, I am able to work from home. I work remotely because Mozilla is really, that's part of the culture there. And so I can really focus and basically not have the context switching of having people come and ask me questions and for meetings and stuff like that. So it makes the context switching between, drawing things out and stepping through code and all of that a lot easier to handle. But yeah, there is sometimes context switching problems, because it is very different when you're thinking about how to explain it versus trying to integrate it into your own understanding yourself.
Mm-hmm. So when do you think that we will be able to see quantum? Should we just get the nightlies and kind of sit on it? Is this something that's going to be done when it's done, or is there a particular date where we'll all celebrate?
Well, Firefox 57 release is the one where we're really pushing to make that be a very noticeable performance difference. And that's, you're going to see that as Firefox official release in November. But there are still going to be other things that come after that release. So WebRender, that's not going to be that use of the GPU. That's not going to be there in 57. That's going to come later. So we expect that people are going to see a big difference in November, but they're going to continue to see more and more performance improvements even after that.
Very cool. I saw a really interesting article in ZDNet that said why you should root for Mozilla's Firefox. And there's a lot of people talking about what they call browser monoculture and how we may have felt weird during kind of the quote unquote browser wars, but it made the web better. Do you think that we should just have one browser to rule them all, or do you think that there's something to be said for us to all push on each other in a friendly way?
Oh, I definitely think that having the browser competition, having a browser landscape that has multiple browsers is very important to making sure that we keep the web as a platform that's not owned by any one corporation. Because I think we've seen what happens when you allow information to be owned by a single corporation. And we're seeing it more and more. I don't think that's the future that we want for the web. And so I'm really glad that we have had this focus on improving Mozilla's performance and making sure that it's still a browser that is, that people really, really want to use, because it's important for Firefox to be there to keep that browser competition going.
Mm-hmm. Yeah, I definitely agree. I mean, even though I could say in my day job, I work at Microsoft, I've got all the browsers pinned and I want to bounce between them. And sometimes I'll just use a browser and spend some time there. And ultimately, you've got a good browser if the browser itself disappears and you just forget what you're running and you're just on the web and you're having a good experience.
Mm-hmm.
Do you think that Mozilla would be a project that people could get involved in? Or are there particular things that, from an open source contributor perspective, you're looking for? Do you need experts in 3D or in gaming or testers or documenters?
Well, there's definitely needs across all of those. And different parts of the project, are working with different tools. So if you like Git, you might want to work on the servo side of things. If you're familiar with Mercurial and if you want to work in C++, you might want to work on the Gecko side of things. So different parts of the project are good for people who have different skill sets. But yeah, we're definitely looking for people who are wanting to contribute in a whole different variety of ways.
So I went to wiki.mozilla.org and I just scroll to the bottom and there's a whole section there that says contributing to Mozilla. And you even have a student ambassadors program that people could probably communicate with you or other Mozilla employees on Twitter and learn more about that.
Yes, for sure.
So we can find you at hacks.mozilla.org. We can learn more about Mozilla and the project itself at wiki.mozilla.org. Of course, download Firefox and get ready for Firefox 57 coming later this year.
Great. Thank you for having me, Scott.
Thanks for hanging out with me today. This has been another episode of Hansel Minutes. We'll see you again next week.